Hello, Randy, K7AGE. I'm going to show you how to receive slow scan pictures from the International Space Station. Here we go. I may be leading you down a very frustrating path trying to receive images from the International Space Station. But I'm going to break it down into some manageable steps to give you a better chance for success. And you will be able to make this work. You may not receive any images during your first pass, but keep at it, you will be able to make this work. And when you see your first image, it'll seem like magic, but it's not. It'll be due to your hard work of being able to receive images from the International Space Station. Once you get this working, it's fun to show it to your friends and family that you're able to receive pictures from space. And this is also a good club project to get people involved and learn a lot about tracking, slow scan TV, and pulling all this together. Receiving SSTV pictures from the ISS is not hard, but it does require a few things to be set up in order to do this. This video is being recorded a few days before a December 2021 ISS SSTV event. So this event starts on December 26th, the day after Christmas, runs through the 31st. So it'll be on for 7 days, 24 hours a day. A perfect opportunity. Gives you a lot of chances to be able to receive the images. Typically they run through a rotation of 12 or 16 images, so the goal is to be able to receive them all. Maybe not perfect, but you have your collection. There are other SSTV events during the year, and you have to watch the times carefully because sometimes they'll post them out, and you can find these from ARL or AMSAT, US or UK. And the times will be very limited, and you wonder why they're doing that. Well, it's probably because it's a SSTV event from the Russian side of the ISS, and they turn the thing on while it's over Russia. So your chance of, if you're in the US or other parts of the world, are basically zero. I've had people talk to me on the radio, said, I've listened, I didn't hear it. I said, well, it's only on over Russia. So you kind of got to look at that carefully. For this event, Eris is hosting the event. I believe this to mean that the radio equipment is on the Columbus side of the space station using the Kenwood radio. There are many antennas on the outside of the International Space Station, some outside the Columbus module and some outside the Zeta. I believe that's how they pronounce it, module. I may have this wrong, sometimes it's difficult to dig up the information. But the radio runs high power. It's not like the satellites that run a quarter watt or a half watt. This is running, I think, 10 to maybe 25 watts during the pass, which means it betters your chance of receiving a strong signal. Okay, now let's get into the details of how to do this. That's why you're watching this, right? Not for me ramble on for a long time. Anyway, first thing is, when can I receive the ISS? When is it over me? 2, how do I receive the ISS? What's required? Not a lot. 3, how do I decode SSTV? And there's a lot of possibilities that you can use. So the first thing is, when can I receive the ISS? This involves using satellite tracking software, and you select the ISS for the satellite that you want to track. And you have lots of choices for tracking programs. There are web-based programs. You can get programs that run on your iPhone or your Android, and lots of different Windows programs. The web-based program that I recommend is from heavensabove.com. And this is because, first of all, it shows you where the space station is on a map. And secondly, you can enter in your location just using a zip code or city, and then you can get a prediction. I also use this as a reference when I have other tracking programs that I'm using, so I can compare what's on my phone to what I see on Heavens Above. And if the space station appears in the same position, I know I have my other tracking programs set properly. And sometimes you can miss things like your location. If you enter it in as Latin LAN, you may have a plus sign instead of a minus sign. You may have your time zone wrong. There's a lot of things that can cause the tracking program to show the space station where it's not. And you'll waste a lot of time trying to be looking for it, and it's not there. It's somewhere else. Let's now go to the heavensabove.com webpage and see where the ISS currently is, how to set your location, or my location, and how to do a prediction so you can have a list of when the space station will be over your location. Here we are at heavens-above.com website, and one of the first things it shows me here is the current location of the ISS. Now, this is not a real-time tracking, so always refresh to make sure that it's accurate. So here's showing the space station between Africa and Antarctica. I use this as my reference when I'm setting up other tracking programs. If they're set right, if I have the location right, the time right, if I have an up-to-date orbital element set, the two should agree and show the position at the same place. If not, something is wrong with the other program. This one's, as far as I know, is always right. So what we want to do next is change our observing location. So I can select that, and it brings up a map. It shows a pin here of my location, but you can zoom out the map and say, using the left click, put yourself in New York City. I don't want to do that, because now the predictions would be if I was located there and not here. Another way you can do this, you can put in a city. I can put in my zip code, 97444, and do a search. It puts the pin here basically in the middle of the Rogue River, which is close enough, and make sure I push the update button. And if I look up here in the top right, it should now show that position, Curry County, with my Latin Lodge. Now we want to do the 10-day prediction. So 10-day predictions for satellites of special interest. We want the ISS. It defaults to show visible only passes, which is fine if you want to go outside on a clear night and be able to see the space station going over. This will tell you when and where. We're interested in radio, so we want all the passes. There's three main areas here. So we have dates, and the three main areas are the start of the pass, the highest point of the pass, the highest elevation above the horizon, and the end of the pass. Now this program defaults to only show passes above 10 degrees elevation, 10 degrees above your horizon. So the start here is at 4:53. It'll be 10 degrees at looking south-southeast. The highest point is 13 degrees at 4:54 to the southeast, and it ends at 4:56, again at 10 degrees to the east. So this is about a 3-minute pass. You're not going to be able to do much. The SSTV images takes 2 minutes to transmit, and they typically have a 2-minute transmit cycle and a 2-minute receive cycle. And then it comes back, 2-minute transmit cycle. So 3-minute pass, good luck. The next pass is at 6:27, west-southwest. It peaks at 6:31 at 79 degrees. That means it's practically overhead to the northwest. And it sets at 6:34 to the northeast. So that is about a 7-minute pass. Again, 2 on, 2 off, 2 on, 2 off. So during there will at least be one complete image that's transmitted in your view. So this is your schedule when the ISS will be above your location. If you don't want to use any other tracking programs, select this, print it out, and you're all set. And let's take a look at the AMSAT.org prediction page real quickly to give you a second one to check out. Here we are at the AMSAT.org. You can find predictions under satellite info, past predictions, and you can select which satellite from a list. We want ISS. You need your grid square or your latitude and longitude. I'm going to enter in my grid square, CN72, and hit predict. it came up, says no valid latitude or longitude. It'll attempt to compute that from the grid square, which it does, and then it goes to this window here. I find this not as easy to use as the heavens above, because this is in UTC time versus your local time, and that's probably what you're going to be mainly concerned with. Whereas the other one, it broke down the time and the angle where the satellite started from, the maximum position, and the end. So here it's here's your direction for the start of the pass, the maximum elevation at this azimuth, and then it sets at this azimuth here. So just another one to try. Now let's look at a program I use on my Apple iPad and my iPhone. It's called GoSAT Watch. And it's not free. It's about $10. There's a lot of them out there, but this is one I use. So I'll show you real quickly how that works. So this is GoSAT Watch. Let me bring that up. And the way I have this running is just in a world map, which you can move around. You can also get it in a globe type of thing where you can spin it around. That's kind of neat. We go back to the regular map here. Here's where the IS is. We'll check that here in a second. There's a couple things you got to set. So you go into settings, and the first thing is your location. And I have mine in here. You can just use current location. It'll try and figure out the best through the networking, or you can edit and add a new location and enter latitude and longitude. And that's basically about it. Preferences, whether or not you want the Earth night, metric units and things like that you can play with, what your minimum elevation is. Set to, I have it set to 0. And I go back here, okay, and go to here. You can go to satellites, and depending on what type of satellites you have entered in, you can select between different things. And this little refresh thing up here at the top will download the new 2-element Caparian satellite elements, so the computer here is figuring out the orbits correctly. And I have amateur radio selected, and I go to info. Here's a whole list of amateur radio satellites, including the space station here, and I have that selected. I only have one selected here at the moment. So that's showing you where it is. And if you want to do a prediction, you can go to passes here, and it's going to calculate, and it now has come up with a series of passes. If I press now, it says the next one here is at 2:34 my time. It starts at 2:34, ends at 2:38, a peak of 1 degree. And if I select that, it'll bring up this little radar, and you can see it will just skirt the horizon. So that's a nothing pass. Next one's let's look at this one here at 64 degrees, and you can see that's going not quite overhead. But anyway, that's Go Satellite Watch, and let's compare this to heavens above to see if we're tracking properly. So here's the two side by side, and gee, it's not, they don't match at all. Here it is off Africa, south of the United States, but make sure you hit the refresh screen, and there it is. You can see it's right off the edge of Africa there. So I know this is now working properly. Then there's many programs that run on your computer in both Windows, Mac, and Linux. Now, I'm a Windows guy. I don't know about the Mac and the Linux programs. Search for satellite tracking. I'm sure there's a bunch of them out there. Look on YouTube, you find videos there. Orbitron for Windows is what I use. It's free. It's a little extensive, a little complex. If you don't get it set right, it'll give you wrong information. And this is why I like the web-based things for the beginners. But let's take a look at this quickly. So here's the main screen in Orbitron, and main tab down here. So this shows me the position of the, or location of the ISS. It shows the coverage circle, so any stations located within the circle will be able to receive the satellite or the space station. It shows the upcoming orbit path. You can see it's going to still be quite a bit out to the west of me. Moon, sun, and my location. You can go zoom, right-click on the map, and say bring up North America. Zoom and go back to normal. You set your location with the location tab. Here I've entered in my location. I use my call sign for the name. I've entered in the my grid square, or you can do your latitude and longitude and set your elevation. To do a prediction, you set up your prediction. If you go automatic, it'll do it in days, hours, or minutes. If you go manual, you can enter in dates like 12/26 through December 31st. I have it set for a minimum elevation of 5 degrees. If I go to prediction here, it's empty at the moment. I'm ready to predict. It runs the calculations and it brings up a series of predictions here. So I'm going to scroll down here to this next set, a little more interesting. So here's the time, local time. You can have this for local or else UTC. So I have it local. So at 5:39, it'll start at azimuth of 225 degrees, 5-degree elevation. At 5:43, at 141 degrees azimuth, the ISS will be at 64 degrees elevation. It'd be pretty high. And then it ends at 5:48 at 59 degrees azimuth, again at 5 degrees elevation. So that's Orbitron in a nutshell. It would take me a whole lot longer to go through and explain all this to you, but this is the type of stuff that's available when you run on a computer. Again, beginners, heavens above, do a prediction, get your schedule, and go on to the next part of receiving the event. So the $64,000 question, does Orbitron match heavens above? So let me refresh heavens above, bring Orbitron back up. This shows it, now it's kind of difficult to tell because different projections here on the map, but it looks like it's pretty much due west of me here in the United States, and I see that on here. So I'd say Orbitron is working fine. So you've now learned how to learn when the space station is over your head so that you can receive it. So now to receive it, it doesn't take fancy equipment. I mean, a simple old scanner can take and receive the space station. You know, the common Baofeng is perfectly acceptable. If you have fancier HTs, I have this ICOM ID 51. This works great too with another little feature we'll get to. Anything that receives 2 meters, 145.800 is the frequency the space station transmits on. I'll be using my IC 9700 and my ID 52 here in some demonstrations here coming up. As far as antennas, yeah, what's on the radio, we'll probably hear it, especially with the higher elevation passes. When the space station's coming over, don't point your radio at it, have it broadside. There's a null off the end here. This is minimal reception, and broadside is better. If you have one of these longer antennas, works even better. You can use a mobile radio. Your mobile antenna will probably receive it just fine. For more permanent base station antennas, something as simple as a quarter wave ground plane vertical. I have a video on it from years ago, very popular. You know, 5 hunks of 19-inch wire soldered on a connector and hooked a coax on the bottom. You're up and running. And what I use here for my station, I have a Comet I think it's a GP15. It's a tri-band antenna. It's 6 meters, 2 meters, and 70 centimeters. And it has a very narrow pattern. So wire antenna pattern is something to think about, but don't think too hardly. Since the space station will spend, most of the orbits that you will be receiving on are probably between 15 to 60 degrees. So that's where you want your radiation pattern, if possible. Now my GP15 has a much narrower radiation pattern, which forces more of the energy or the reception window towards the horizon, which you think, well, maybe that doesn't work as well. I've been very pleased with it. It's done really well. I can pick off some of the low passes coming over the ocean. And don't forget, as the satellite gets closer overhead, it gets closer, therefore it gets stronger. So a quarter wave will work fine. And the ultimate, if you have tracking antennas with azimuth and elevation control beams, and it'll computer run, it'll automatically track the space station. That's kind of the ultimate end. This will get you started. A couple other things to think about. On some mobile radios, and like my 9700 here, some of the radios will allow you to select different filter bandwidths. You kind of want a wider filter, because a satellite or the space station, as it's moving towards you, is high in frequency. When it's at its midpoint, it's on the frequency you think it should be, and as it passes away, it'll go lower. This is the Doppler effect. Now, it's not tremendous in the 2 meter band, and most radios can handle it just fine. Don't worry about it, but if you have the opportunity to select a wider filter, do it. It'll help. The next thing you may have to fiddle with is somehow how to get the audio out of here into your decoding program. So we'll cover that more with the decoding programs. All right, now I know when the space station will be overhead. I know how to receive it on a radio. I know what antenna to use. 145.800 is the channel. Now I need software to take and decode it. So, slow scan television. It's really not television. It's a method to send still pictures. It was developed in the late 50s with tube-type equipment and old scope tubes that you couldn't hold the whole image. It would fade away. It was really primitive compared to what we can do today with free software. I like to use MMSSTV for Windows. It's free. So let's take a look at that here. Okay, MMSSTV, as well as several other programs, is available from hamsoft.ca, and he has here several different programs. Now, these really aren't supported anymore, but they work just fine. And what we're interested here is in the MMSSTV program, written by JE3HHT. And so here's where you can download it. There's another version which has been updated. This MMSSTV YONIQ. And I haven't played with this, but this has been more updated. You can see he's changed the user interface, but we'll stick with MMSSTV. This is what it looks like after you install it. So this is kind of a naked version. It's not showing you anything here. But basically, this window here, when you're in the Receive tab, will show you the picture as it's being received. This over here selects the mode. Now, there's lots of different SSTV modes. You can run it in the auto, and it will detect which mode it is when it transmits, or you can manually select a mode here. Scotty, Martin 1, Martin 2. The ISS will be sending in PD 120. So I can right-click on this button here, and there's all the different standards. We love standards. There's so many. I can select PD 120, and that's there. Now, it'll still receive it without doing that, but sometimes it's nice if you have to manually force it into that mode. What we see up here is the spectrograph of the bandwidth of the receiver, and when it's downloading, you'll see a a strong signal spike here at the 1200. That's the sync range. And then the image information is between 1500 and 2300. It has a logging program built in. History, you can see what you've decoded. In fact, there's a view here that says always show thumbnails of history. So these are various images that I've received. A lot of them are just noisy. These are probably off of 20 meters. So I'll just get rid of that for now. Some of the things to set it up, you go to Option, Set Up MMSSTV, and you get this window here. And we probably want to start in the, I got my notes here, in the Miscellaneous tab. So go to Miscellaneous here. And if you have a direct audio connection or a sound card interface or a signal link, that's where you would select that. Right now I'm selected for my 7610. I can select my 9700 for the input. We're not going to transmit it, but I can set it for the output too. If you'd like to see how I change the names of these, leave a note in the comment and I'll show you how to do that. It's pretty simple. Let me see, what else here? You want to have the clock rate at 48,000. And the rest of this you can just kind of leave normal. If we go to receive, we pretty much leave all this alone, although I make sure all of these in this area here are set. So it'll auto start, it'll auto restart, it'll auto resync, it'll auto slant, and it will decode the frequency shift key ID of the picture format at the beginning of the transmission. Squelch level low or lowest, and auto start on the VIS or the sync. Transmit, we're not transmitting, so it doesn't really matter. So let's see this work. Okay, for now a demonstration here, but I'm recording this before the SSTV event, so there's no space station transmitting overhead. So what I have here is my ISS. This is my ICOM space station simulator, and it's my IC 705. And on my Toughbook here, I have a video that I recorded a couple years ago. I have like 27 minutes of recorded ISS SSTV passes. So this is perfect sample files for you to practice with. The link will be down below if you can go and get that. So let's see if it's working here. And let me step forward here and put the radio in transmit. And you can hear it coming out of my 9700. So let's see how MMSSTV decodes this. Let's see MMSSTV receive an image from my ICOM space station simulator here. Let me turn on the transmitter and start the image. There's a signal. Here we go. It automatically picked up PD 120. Let me turn this down now. You can see my sync information at 1200, my picture information between 1200 and 2300 hertz. If you push this magnifying glass, it'll pop open a large image here. And if you may see it kind of align the image here, make it straight. Sometimes it'll pause, then you'll see it align itself and continue. You don't miss anything, but it just kind of pauses while the software is figuring that out. Here's the audio level running here. This looks like a good pass. So I'm just going to pause here for a minute. We'll come back towards the end of the image. you see it? Do you see it slant? Correct? There, it's going to correct. And now we're finishing up the image. So you saw the correction there where it straightened it out. And here we are, we're done. So, there we go. That's how that works. And one of the nice things about this is that it saves all the images here in the history file. So if you see one that you like that came in good, you can right-click on it and save it. I usually save it with the timestamp. So here's a bunch of images that I had received back in June. I'm going to create a new directory here in a couple days. If you have images in here which are poor, you can right-click on it and delete the image. So you can go through and clean this all up. So you can delete images and you can save images. What I do is that come on the first day of the pass, I'll turn on my radio and turn on this, and I'll let it run 24 hours a day for the whole week. And everything that it receives will show up down here in the history file. And then once a day or a couple times a day, I'll go through here and I will clean out different images here. I think it can hold 64. I'm not entirely sure. But that's the history with the thumbnails. So that's a quick overview of MMSSTV. Now let's see another way that you may receive your image. So here's another way that you can acquire your SSTV image, is to break up the process into two parts. So one is to receive it and record it, and the other one is to play back the recording and then decode it. So this is probably the easiest way for first-time users. You can go outside, hold your phone by the radio and record the image. So let's do a recording. Okay, so I'm going to start the recorder. It's recording. And start the playback. So we have it recorded. Well, let's see what we can do with it. Let me stop it here. Okay, I have the file on my phone. I have MMSSTV running on my laptop. I have the audio input selected for the microphone. Let's play this back and see what happens. Okay, well, it's just about done. It's not as good as direct coupling. There's a lot of like room echo and stuff, a lot of weird ghosting in the picture, but hey, it's a start. You start simple and you work to a better setup. Okay, I have this SSTV iPad software for the iOS devices for Apple. It's from Black Cat Systems. It's $2.99 from the App Store. I find it a little finicky to get it going, so I'm going to tell it to stop. And I'm going to start this and see if it starts up properly. That looks better. I had trouble getting it to start from the beginning. You adjust the phase to find the right color and the skew to get it straight. And I'm going to push the save. I'm going to turn this on here. Save to photos, so hopefully it gets saved. And this is a little better, yes, access to the photos. Yeah, because it disappears. So So there, I brought it back from the saved photos. So it's, I don't see as much of this echo and type of distortion as I did when I did it on the laptop. But this just to go to show you that you can do an acoustic coupling, you can do audio recording. You know, if you're able to control this software better, you may be able to do it right into the, having it right by the radio, but if it screws up, you've lost the pass. So that's where recording the audio really helps. And for other software that's out there, I mentioned the Black Cat systems for the iPhone and iPad. There's Android, Robot 36, Multiscan for the Mac, and SSTV for you Linux users. Now, I don't have any experience with these, so you're on your own, or do what you do. You go to YouTube and do a search and find out how to use those programs. One of the things you may have to look at doing is to have some type of audio interface between your radio and your computer. Now, these have been around for years due to, you know, the original PSK31 and now FT8. You know, everything from a little circuit that you can build up to signal links were very popular, and many of the newer, at least large radios, have the USB sound cards built in. But you know, if you go from the speaker out of the radio to the microphone input of the computer, you have to be careful that you do not overload that. You may need to come up with a simple resistor divider, say a 10-to-1 or 20-to-1 ratio, in order to reduce the audio level going into the microphone input. If your computer has a line input, then you're all set. You can pretty much connect the speaker lead right into the radio, and that'll give you much better quality than the acoustic coupling of holding the microphone near the speaker. Another hint is that during the pass, open up the squelch on your radio so that you can really receive down into the noise. Of course, you'll just get noise in the picture. And with radios like the ID51, I'm sure the brand new ID52 and the IC9700 and maybe other radios allow you to record directly what the receiver is receiving to the SD card or the micro SD card that's in the radio. And fortunately, it records it as a WAV file, so you can play it back with a lot of players. Well, that's been a lot of information here I covered. I hope I have everything, and it should be enough to get you started. Remember kind of the three things you need to kind of think about. One is I would recommend you go to Heavens Above if you're not familiar with satellite tracking. Enter your location, get the past prediction when the ISS is over your head. Get your radio ready, 145.800, no tone, no PL, no offset. You're just going to receive. You can use a rubber ducky, a longer rubber ducky. You can use your mobile radio. The antenna that's on your vehicle will work just fine. If you have an outside 2-meter antenna, use it. Use what you have to get started. You can always improve later on. And then there's the software. And again, to start with, there's a lot of things to take and fiddle with. So I almost recommend recording the audio and then playing it back. Is getting used to the SSTV software can be a little finicky, especially like what you saw on the iPad there. And if you're trying to do it live, you may miss that pass. So it helps to record and practice so you get familiar with how things all work. Have fun. I think that's it. I'll be posting my pictures on my @K7AGE Twitter account. And I hope everybody has fun and is able to receive pictures from the International Space Station. 73, and thanks for watching. This is Randy, K7AGE.